Number 23, solve the system by elimination. And again, we have two equations in our system. The first equation is x minus 7y equals 7, and our second equation, 7x minus 6y equals 49. And as we discussed in video 22, what you're deciding first and foremost is whether or not to eliminate the x variable or the y variable. It doesn't matter which variable you decide to eliminate, you will still end up at the same solution at the end. So what we normally do is eliminate the variable that's easiest to get rid of. And in this case, for this system, I would say that the x is the easier variable to eliminate. But because we eliminated the x in video 22, let's go ahead and eliminate the y in this problem so that we can see what happens when we have to manipulate both equations in order to eliminate. All right, so if we're going to eliminate the y's in this case, remember, we want the coefficient of the y variable to be additive inverses, meaning one has to be positive, one has to be negative. Doesn't matter which you want to make positive and which you want to make negative. And the number also has to be the same. The coefficient has to be the same. So if we have a 7 and a 6, what would the least common multiple between a 7 and a 6 be? Well, you could go through the whole process and write out the multiples if you want, but a quick way is to simply multiply these two numbers together, and that will give you a common multiple between the two numbers. So if we take 7 and 6, multiplying together, we get 42. All right? But remember, we need to make one of these coefficients positive, and one we will we'll let remain negative. So I'm going to make equation 1 positive, and I'm making that decision arbitrarily. You could decide to make the coefficient of y in equation 2 positive. And so if we want to make the coefficient in front of y here be a positive 42, we're going to have to multiply this whole equation by a negative 6. All right, and when we do that, we end with negative 6 times x is negative 6x. Negative 6 times negative 7y is positive 42y. So that's why we decided to multiply by negative 6, because a negative times a negative gives us a positive. And then negative 6 times 7 gives us a negative 42. All right, so we've got a positive 42y in the first equation. We want to make this negative 6 into a negative 42. And to do that, we'll multiply equation 2 by a positive 7. And so positive 7 times 7x gives us 49x. Positive 7 times negative 6y is negative 42y. And 7 times 49 is 343. All right, and now we're going to add vertically. Negative 6x plus 49x gives us 43x. 42 minus 42, well, those go away. And then we have equals negative 42 plus 343 is 301. And if we're going to solve for x, we need to divide by 43 on both sides. And so x equals positive 7. All right, so we've now solved for x. We still have to solve for y, and to do that, we're going to take this x value and plug it into really either of the 4 equations we have. We have the 2 originals, and then we have the 2 equations that we manipulated by multiplying by different scalars here. I always recommend taking the value x or y and plugging it into one of the original equations, but it really doesn't matter. In this case, we have 4 different equations to choose from. So if we take this x value and plug it into, and again, I'm going to choose the first equation here, for x, well, then we'll have 7 minus 7y equals 7. I want to solve for y, so I want to start moving things away from the y. I'll start by subtracting 7 from both sides. That leaves us with negative 7y equals 0. And to get y by itself, we'll divide by negative 7. And so y equals 0. All right, so now that we've solved for both x and y, we're going to write our solution as an ordered pair. So x comma y. And like we mentioned in video 22, it is a really good idea, especially on tests, to get into the habit of checking your solution. So let's go ahead, take our claimed solution, plug it into each of these two equations, and see if we get a true statement. Remember, we have to get a true statement for both of these equations in order for this ordered pair to be a solution. So if we take our xy, plug it into the first equation, let's see what we get. So we end up with x, but x is now 7, so 7 minus 7y, but we're saying y is 0, equals 7. The parentheses can go away. We'll distribute that through. Negative 7 times 0 is just 0, so we can say plus 0 or minus 0, doesn't matter, equals 7. Well, we know 7 plus 0 is just 7, so 7 equals 7. That is a true statement. All right, let's see if our solution here works in equation 2. So we have 7 times 7 minus 6 times 0 equals 49. Well, 7 times 7 is 49. Negative 6 times 0 is 0, so that goes away, equals 49. This is a true statement, and so it also works in the second equation. And the fact that it works, this ordered pair solution works in both of our equations, this is a solution to the system. If it only worked in one of the two equations, it is not a solution. And of course, if it doesn't work in either of the two equations, it's definitely not a solution. All right, but number 23, our solution to the system is 7, 0.